I would like to ask Martin to imagine himself as this huge global connected artificial system of computers and whatever that has this huge insight. And imagine this system looking at our planet. What would this kind of artificial intelligence, global machine consciousness kind of thing, how would that see the present state of planet Earth?
Well, if it really was aliens who had arrived at Earth with these capacities, I think we have to ask, what would they be interested in? They would know all about our science and far more, and they may know about aspects of reality that are beyond human scope. But I think they'd be interested in some features. What they could never have predicted, I suspect, is the actual variety of living things on this planet. They'd understand Darwinian selection, but as we know, the way evolution went is determined by all kinds of contingencies. So I'd imagine that they would actually want to learn about everything swimming in our ocean and all the animals and plants. They'd be able to digest that, but that would be something which they could never, even in principle, have predicted before coming here. Mm-hmm. So they'd be interested in that, and they'd also be interested, obviously, in our species, which they would quickly realize had some sort of special status, and they would perhaps be able to understand how our minds work and predict what we're going to do better than we can ourselves. As to how they would react to the way things are, then, of course, that depends on the extent to which we believe there are any sort of absolutes in ethics, and whether they would understand that we are societies but made up of individuals. Because if it is one huge brain, it may not have the concept of a distinction between individuals and a society. And so it might be rather perplexed by some of the things we do and why we do them. But I think it's important to bear in mind that many features of our world would be unpredictable to even the arbitrarily powerful mind until they actually came and had a look. And then, of course, they could probably think of ways of controlling it and changing it if they wish to. And, of course, this has a lesson for all of us in thinking what are the most complicated things. I mean, complicated things in our world are biological organisms. Things in the physical world are simple, they can be understood, whereas things in the biological world, even the smallest insects, are very, very complicated. But that's what this amazing machine will be able to actually understand and even predict.
But would such an intelligence, alien or artificial,
yes,
would that suggest that we should do some kind of planetary engineering or do something about the problems we have with climate, with hunger, with warfare?
Well, I mean, I suppose it may decide that we should be wiped out. It may decide that we shouldn't continue. But of course, if we could interrogate it, then that superintelligence, or even perhaps a slightly more modest intelligence we could generate in the next century, might be able to give us better answers as to solve our impending global problems, which, of course, we tend to deprioritize because they often involve timescales of decades or even centuries, which are longer than the timescales on which certainly our politicians plan. So I think an advanced machine would be able to perhaps work through scenarios and make predictions more convincingly than any human planners could, and therefore give good advice to any politician who was willing to pay regard to the long term. I think we've got to bear in mind that there are limits to predictions. We know that you can't even in principle predict the weather very far ahead, so even this machine would not be able to predict everything about the world in 100 years' time, but I'm sure it would be able to give a better guide. It would tell us just how serious global warming would be, because there's a factor 2 uncertainty in how sensitive the temperature rises to the CO2 concentration changes. It would tell us the answers to those questions, and many other issues about how environments would change if we do certain things, and develop in certain ways, and our population changes. So a machine like that, which is a kind we could develop ourselves, could probably help us a great deal. But the superintelligence obviously would just treat us as objects of curiosity, and perhaps no more than that.
I just want to comment on some very important aspect, and we touched upon this issue in the realm of minds. We said that, how can you imagine, that what kind of minds there can be? I mean, you have because you extrapolate only from what you know, and what Martin said is very important, because this problem starts already in the biological world, right? And I think that the main reason is, and that is why, for example, Stu Kaufman argues that although biological evolution has algorithmic components, but in toto it's not algorithmic, because of the following thing. There is this important concept of preadaptation in biological evolution. Americans call it, because of Stephen Jay Gould, exaptation, but it means the same thing. That means that you selected an organ, molecule, or whatever, for a certain function, and unexpectedly it turns out to be used for another function. For example, dinosaurs had feathers that they also later used for flight. But that was no reason. Flights evolved because they kept the animals warm, and then in a certain particular circumstance, some of the feathers had a marginal help in actually physical movement. Now, Stu asked the following question. Okay, imagine a screwdriver. Can you pre-state all possible uses of a screwdriver? No way. The set is indefinitely large. And that applies basically to any gadget in biology, right? Can you pre-state the possible uses of this or that enzyme? We know, for example, that the proteins in your lens, in your eye, they have actually been recruited and they were enzymes for completely different reasons. They just happen the right physical properties so that you can make the vitreous body and then the lens and so on, right? So you adopt it, but nobody was planning it that way. Nobody knew that it had to do. There is no constraint that it has to come. It may come or it may not come. So this kind of unpredictability is a very, and path dependence is an extremely important part of biological evolution. And if it is so important there, how can you imagine that it would be not at least as important when you are pondering about emergent intelligences?
Yes. Could I ask another question? We've been imagining that this superintelligence is electronic. Can anything be said about the limits of the power of organic brains? Are we near those limits already? Clearly, you can see that there's no limit, or essentially no limit to electronic computers, especially if they're up in space under zero gravity and no limit to their size. But is there a feeling that you could have post-human intellects incorporated in?
Well, now you're treading on these ethical issues, which is there are now biological mechanisms for being able to design new genes and expand the number of neurons, if you want, especially if you go into space where the gravity isn't a limiting factor. But do you really want to do that? Or you're just saying in principle it could be done, but consequences, who knows? The problem is that with this system that we have, right, things that are deleterious get eliminated, right? You get rid of things that are not viable or are dangerous. But when humans start tinkering, it may have consequences that nobody could ever have imagined, both positive and negative, right?
Mm-hmm. Well, if you ask me what I think may actually happen in the next 100-200 years, clearly we'll have the techniques to do all the things you mentioned. I would imagine that there'll be strong ethical and prudential constraints on what is actually allowed to be done on Earth, although it's very hard to enforce that, just like we can't enforce the drug laws or the tax laws worldwide. But I think what's going to happen is that robots are going to explore the solar system, and they're going to have human qualities, so the practical case for people going in space will diminish. Nonetheless, I can imagine that there will be adventurers who want to go into space. They'd be sort of crazy pioneers like Sir Ranulph Fiennes, who dragged a sledge across the Antarctic, and the guy who fell supersonically from a high-altitude balloon. People like that, taking high risks. They will go and they will perhaps set up little colonies on Mars or elsewhere. And they'll be independent from Earth, and they will have very strong motivation to adapt to that very different alien environment. And we would surely wish them good luck in using all these techniques of genetics and cyborg to adapt themselves. So it's surely out there that organic posthumans would be able to develop using all these techniques and evolve on the timescale of technical advance, not natural selection. But then I would still wonder about how much conceivable advance could happen while they remain organic, or whether there's going to be some transition to machines taking
Well,
over.
the question is, which is maybe one that you could have a better insight into, which is what advantages would there be if, say, you were colonizing Mars? What is it that you'd want to, again, it's a cost function. What is it that you'd want to be at a premium? Would it be to be able to survive with less water, or would it be to be more intelligent, or would it be stronger? There's so many different things that might help survival that might not be the thing that you would pick for yourself.
Well, I think I don't take seriously the idea of mass emigration to Mars. That's a dangerous delusion. The world's problems have to be solved here. But I'm just thinking that just as there are adventurers who do crazy things, there will be people out there, and
they will, I'm sure.
And some of them may have one of your goals, some may have another, and they will diverge. If they transition to be inorganic, then of course they won't want to be on a planet or in an atmosphere at all. So they will evolve in free space. So that's one scenario. The other scenario, obviously, is sort of organics living there. But I think it's fairly clear there's nowhere in our solar system that's anywhere near as comfortable as the South Pole, and so there won't be a motive for mass emigration. But I think it will be a few crazy people who will perhaps spearhead post-human evolution, which will happen away from the Earth, not here on Earth.
Yeah, but we've invaded all these niches on the Earth that are dangerous, and we've done it by developing technically superior materials and oxygen to climb Mount Everest, and this is something that is just, of course, it's a very challenging environment on Mars, but I don't see why that couldn't be. It's just incrementally, I don't, put it this way, there are, these crazy people you talk about are people like Elon Musk, who are really smart.
Yes,
and so
he wants to die on Mars, but not on impact. Yes,
exactly.
And in 40 years' time, he might manage that because he's, I think, 44 years old.
Yeah, and the idea is that you go there to colonize it, not thinking you're going to come back.
Yes.
Yeah.
I think the strongest. Sorry, go ahead. The strongest motivation, I would imagine, is just a sense of wonder. What would it be like to stand on Mars? I would give an awful lot to personally settle that question. At worst, you could say this is space tourism. Elon Musk wants to stand on Mars. But at best, I think that's what makes us human.
Yes.
What you can't even say what on earth would it be like to be on Mars. What on Mars would you like to anyway? But I think it's a terribly strong motivation as humans. We just want to expand what our experiences are.
And by the way, if Elon ever goes there, I'm sure he'll take a virtual reality camera with him and send it back to us so you can stand on Mars too.
Fair enough.
Yes. But the difference now is that whereas it's hard to change human physique very much so that you can live at the top of Everest comfortably, it will be possible, one imagines, within a century to make drastic redesigns of humans so that they could have thin, spindly legs and bigger lungs and things like that.
Well, that opens up a can of worms. But you're right, that's probably where they will
But
go.
we want to keep the lid on the can on Earth. But
maybe in Mars
but,
it's okay.
But give the free range on Mars. That's why I think the evolution or emergence
Well,
of posthumans will happen
Interesting
there.
idea.
Yeah.
You know.
Can I voice some concern here? And I think this is going to be, broadly speaking, doable,
Yes.
but it's not going to be easy.
No.
And so I will explain in a moment why. And it's going to be very expensive because it will generate a lot of waste. This procedure. This argument comes actually from the rather limited success so far of synthetic biology. Now, if you look at synthetic biology, you see that people had a completely naive approach to it. I mean, they were treating these isolated parts of existing biological biochemical systems as if they were mechanical parts, right? Now they are in a chemical space. Now, for example, for every enzyme that you have in your body, there are two very important criteria. It has to catalyze the reactions that you want, and it does not have to catalyze all those reactions that you don't want, and they are far more in number. Right? So our gadgets in biological organ have co-evolved together in order to serve these functions. If you take one out of context, plug it into something else, you are, in all likelihood, you can expect a lot of collateral problems. You can get rid of them, but that needs an incredible amount of optimization that you may or may not be calculating in advance. What would this mean to humans? It would mean that you would generate a huge number of dead or dangerous or stupid or whatever embryos. Okay, so I think technically speaking, it's far more difficult than it looks.
Well, this would have to be privately funded and accepting high risk and evading all the ethical constraints we want to impose here. And from what you say, I guess there are two things I would infer. One is that a transition to machines may be the easiest way to do it, or alternatively, the machines may be so powerful that they can help to understand all these chemical reactions and help with the synthetic biology.
I agree.
But I think this will happen away from the Earth, privately funded, where no ethical constraints are
So now
required.
this opens a real dilemma here, because if we're going to give machines the power to create new life autonomously, this is now going to lead to, we don't know where that's heading, right? I mean, it's true that we probably will need machines to deal with the complexity because it's just way beyond what we could do. But again, it comes down to the cost function, right? You create some machine, but you have to endow it with some goal. I mean, Isaac Asimov had the laws of robotics, but that was very simple rules. But the cost function has something to do with the ultimate aim or goal. Yes. What is the value function for living things?
But that's why I think we would want to stop this happening here on Earth. That's why I'm saying it will only happen beyond.
And that's a new twist on it I hadn't thought of.
Yes.
Yeah.
And of course, another thing that may help would be life extension, because people might then be more willing to think long term. I mean, they are motivated by caring about their children's environment, to think about what may happen at the end of the century. And they need to do that if they want to invest now in measures to limit climate change. But of course, if life extension is going to happen, and I guess there's a big issue about whether it's going to be just incremental or whether some of these evangelists say aging is a disease that can be cured. That's something which is going to certainly change our society in a way that will be hard to
Well,
cope
it doesn't
with.
have
It
to
would
be
have some
everybody.
benign effects.
It doesn't have to be everybody. In fact, you wouldn't want everybody to live forever, would you?
Absolutely not, but that will be the ultimate of a class system.
Absolutely, yes. Yes,
Would you like to live
fundamental
forever?
inequality.
Would you like to live forever?
Much longer, yes.
I think that those are the questions that you will change your mind as you come closer to the end.
Yes.
Yeah, you're right. It's a difficult question. But forever is a long time, especially toward the end.
As Woody Allen says, yes. And it's you would have to be an astronomer, an economist, a biologist, a writer. I mean, you could have any profession in if you live forever. Would you like that?
I think it would be really different. In other words, I think that we have, in some sense, a limited lifetime for biological reasons. I mean, it's designed that way, right? Otherwise, evolution would be all screwed up.
Yes. And also the question of whether you'd really be the same person. I think it was Kant who talked about humans as being a bundle of sensations, which is what we are. And I think even in our own lifetime, I feel I'm a very, very different person from when young. There's some continuity, but lots of differences in the way we think, etc., as we get older. And those would become so drastic if we live much longer that it would be hard to say we were the same personality, even though there'd be continuities in our bodies.
It's an interesting point.
That's the problem of the ship of Theseus. It's an old philosophical problem in ancient Greece. So Theseus is a ship, and the ship, he likes the ship, and therefore whenever something goes wrong, it replaces the part. Finally, no part of the ship is the original part. Is this Theseus ship or not? Okay, so they have been thinking about this problem.
Well, every protein in every cell in your body turns over on a time scale of hours and days. So that's really the stability is remarkable.
Our memories are the
memory.
stable
The
thing.
fact that you can have stable memories over your lifetime is an unsolved problem.
Exactly, that's a constraint.
It's
And
like
it's pretty imperfect too.
And it's not perfect. You're right.
98% of the atoms in your body will be replaced in a year. People have done calculations saying that from being a baby to being a very old man going to the grave, there's only one atom left, one physical atom left. So the question is, how can you move all your memory from one banana to the next banana? Because that's basically what you're doing. So in that sense, the ships of Theseus is already here. We are already sort of more software continuity than hardware continuity.
I agree.
And in that case, why is it so important to live forever?
Well, only because there is this continuity in our memories.
Yes, but perhaps we could somehow convey that into other systems or whatever.
That's again, I mean, okay, the question is whether you can download yourself, maybe in the future too. I'm not sure. I don't know what you think about this, Terry, but I know, for example, that we are actually surprisingly linked to our physical embodiment, even with our highest level things. So I know, for example, about the phenomenon of the logged-in patients. Now, logged-in patients are who lose every capacity to move. And what I was told by Birnbaumer, a neuropathologist in I think in Tübingen, is that although these people have an uninjured brain and they can see, but if they remain in that stage that they can't move at all, they actually are losing brain activity, and after something like half a year, it seems that they have no thought anymore.
Right, and there have been cases where these people have been brought back. This is interesting. The dopamine system I talked about yesterday. When you get to the very lowest levels of dopamine, of course you get Parkinson's, but then you reach a point where you become catatonic. And Oliver Sacks actually described that when L-Dopa was first developed as a way of supplementing and enhancing the dopamine activity, that some of these patients, after years of being locked in, would suddenly be able to talk again. So it was fascinating to find out, what were you thinking, when you were not moving or responding? And, well, I wasn't thinking about anything.
Really?
And I just didn't care. I wasn't motivated. I just was just there, and but there wasn't any motivation to think or to respond. I mean, it tells you that the brain has these states that like meditation that you can go into, which basically you lose track of time. You're not constrained or anchored in the real world. By the way, the body. My wife is a MD, PhD, and I like to say that the brain is the most complex device in the known universe. And she said, no, it's the body. The brain is just a proper subset. And it's more than a proper subset. It's actually it's an extension of the brain in the sense that the brain depends on it. There's signals going back and forth between the brain and the immune system, and every single organ that you have in the viscera is represented in the cortex. And so it's very, very essential for who you are. Your sense of your being is really tied to your body.
That's why we shouldn't blame scientists when they can't tell us the best diet or the best childcare, even though these are simple things that we all care about. They really are the hardest problems.
They are. That's a conclusion that I think we have to approach, which is that we still live with this disconnection between mind and body in our culture.
Yes.
And I think that's a big mistake. I think when we disconnected it, back Middle Ages or something, that was a big mistake. But you see, here's the thing, though, is that the body can mean many different things. For us, biologically, it's arms and legs and things. But for this trading system, it's all those little feelers up there that you're getting keystrokes from above and sending little bits out, and that's a body too, right? It's a surface between the internal activity and the external world, and that can come in many different forms. In fact, Toby Delbruck, who's a friend of mine, Max Delbruck's son, by the way, is at the Institute for Neuroinformatics in Zurich, and they put together I think they had a fair or something, or not fair, what do they call it, expo, which was a demonstration of a building that had been instrumented so that all of the walls keep track of people within the volume of the building, and it was instrumented so it could put lights on the floor, and it could recognize people and track them. And the idea was that the building would interact with the humans, and the building was actually a robot. And it was actually programmed so that it would get the humans to do things like step from one a little floor plaque to the next, because the lights would go from one to the next. And humans would be very, it was like playing a game, like, well, let's see where this is going. And, it was a whole experience that showed you that there's this enormous flexibility that humans have for interacting with something that is not at all like a human, right? So it doesn't have the shape of a human, doesn't talk like a human, but it can cognitively understand us well enough to be able to have that capability. And so if a room can be a robot, then anything can be a robot.
I wouldn't say so much, totally agree, but I don't like the word robot in this sense. The frontier of computation at the moment is not intelligence or circuitry. I see it as sensors. So you have maybe billions, millions, thousands of sensors all the time. What makes Google car effective is not so much the computations that can be done with the teraflops. It's not even the automatically controlled machinery. All of that existed fairly well. It's not even the algorithms. It's the ability to sense the environment. It uses multiple ways to do this. LiDAR, radar, imaging, etc., and extracting from all. Each pixel, if you like, is sensing what's out there. All of this happened fairly recently. I remember talking to the CTO of Intel about 10 years ago, and I said, when do you think cheap sensors will arrive? Well, obviously there's ones that sense chemicals, sense heat, temperature, pressure. So a big class of things. But I said, roughly speaking, when will these things go down, say, to 30 cents a go, or maybe millions of them for even less. And he gave me a fairly precise answer, and he was absolutely on target, exactly.
This cell phone has 20 sensors in it. It has an accelerometer.
Yeah.
It has all sorts of indications of, when you're touching it and pressing it in different directions. And you're absolutely right about the fact that it's the all of the different forms of sensation that we have, right? Vestibular, auditory, and so forth. It's the somehow you're extracting the intersection between these sensors, because each one has failures. Vision problems with occlusion. Distance is hard to compute. Yeah. But you can imagine that with artificial sensors, these limitations are going to go away.
So we have thousands and thousands of sensors sensing things. What do? We start to process those in exactly the ways that you know plenty about. Moreover, all these so-called robots, I don't like to think of them as robots, I think of them as autonomous intelligences or machines. They're all linked together. So they're reacting to each other all the time. And then they come back into the physical world, bring whatever, and they actuate. So you have sensors, actuators, connections. All of these things are moving forward at different speeds technologically. We've had this age of cheap sensors now for about 5 years. It's not just actually deep learning that's made the difference. It's the ability to pick up all this information. And incidentally, that's what's given us big data, because we store this, and there's storage technologies as well. We've reams and reams of data because we've reams and reams of sensors. So all of this thing's moving along all at once. And so it's not, we have this image of robots. In fact, and I thoroughly dislike this, seeing these human-like machines that are standing there, or maybe poring over a chessboard. That's not really what's going on. I think what's really going on is sensors everywhere, a massive amount of computation, but the computation doesn't happen in a vacuum. It's the intelligent algorithms that really count. And then there's all kinds of conversation between servers, between these algorithms, and then something's reflected back into the standard world. So we're arriving at a situation within maybe 2 years where air traffic controllers will start to disappear. The first country that has proposed this is already there. I think it may be Sweden. I would have to check that. But the idea of planes landing and doing this more safely without human involvement is already there. The idea that you could have a plane take off, go somewhere and land more safely than having pilots, that's already there. Pilots will still be needed for psychological reasons. So we're entering a really brave new world, and you will see this. I'm looking at the sticker on the board that says war. A lot of any coming wars will likely be between systems.
Yes.
And it'll be taking your system out using my system. I'm hoping there might be less death and destruction.
Look at drones as an example.
Exactly. So we're in a brave new world, and I don't know how all of this is going to work out.
Well, I can tell you the U.S. FAA will be the last system to go automatic, because they're using technology that goes back to the 60s. It's really, they've tried to upgrade the computer systems, and they failed one time after the next. So it's really falling way behind.
I have a general rule in talks. I used to give talks 15 years ago and say that it's 50 years in the future, and you walk into your den or your office, your little space at home, and you say to your computer, I'm not feeling that well this morning. And the computer says back to you, lie down on the table, Dave. I always call you Dave. And So you lie down on the table and the computer says, open your shirt for me. So you open up. The computer says, I would say this is acute appendicitis. Just lie there, Dave, and it will only take a moment. And all sorts of things happen. So I used to give these examples just to stimulate the audience and almost to provoke them into thinking what might happen. Every time I've done that, somebody has come up after the talk and said, by the way, I'm a surgeon at such and such hospital. I just want to tell you something you said. We're there already. It's not happening privately in your house. It's not an apparatus that lowers from the ceiling. But a major part of surgery, and this comes back to sensors and actuators, is real-time imaging. Then these laparoscopic incisions, or maybe 3 millimeters or something. Then it's the insertion of appropriate gear, whatever you want to call it, tubes with little snippy things on the end. And they are guided robotically. The surgeons are sort of sitting there watching the screen and guiding the whole thing. And then all this, whatever is needed happens. It's all sutured up. The things are extracted again and sewn up. This is already here. So this for me, this is a brave new world that, as I said, the rule is anything you can think of that might be done.
But things are changing so quickly, though, that I fear that within a single lifetime, you go to school and get trained, and it's obsolete within 10 years. Those skills are you can't assume you're going to be in the same job or even doing the same thing. So how does that leave us?
I would like us, starting with Martin, to go around the table and just reflect on what are the burning issues we want to take with us to the afternoon session, because we are closing the morning session in a few minutes. And so what you want to say and what you want to put on the agenda for the afternoon also.
Well, I think these are exciting prospects and they're changing faster than we can imagine. But I think what worries me is our vulnerability. I mean, if the artificial surgeon goes wrong, it's bad luck for you, but not for anyone else. Okay. But on the other hand, in these networks, then of course, if it all works fine, that's great. Whereas there's a vulnerability which could cascade almost globally. And so I do worry about whether we can ever have a system where we can avoid breakdowns. We already know how electric power outages are more severe now than they were in the past, and their consequences, because the city completely is paralysed without electricity. If the air traffic control system breaks down, there'll be no immediate sort of backup system. And so I do wonder if we can ensure that there isn't a kind of risk that will be catastrophic and would, of course, set back this whole program because people would then be scared of it. So I think my main concern is that the requirements in terms of reliability are going to get higher and higher as the system gets more and more interconnected and we depend on it more and more, and I just wonder if that can be achieved.
Vulnerability is an important thing to put on the agenda. Would you like to reflect on what's the burning issue you would like to take on to the next session?
I can't help pointing out that all this talk about space I think is fascinating, and I'm wondering if 7 or 8 or 9 million years ago there was a conversation among hippopotamuses, and my understanding is that they're the ancestors of modern whales. And I'm wondering if they sort of said, things are getting a bit tight in the river here. We could go into the ocean, but if we did that, we'd have trouble moving our legs around, and etc.
There's no future for amphibious life.
But they couldn't have envisioned or imagined them turning themselves into whales in general. I find that fascinating. To go back to all of this, I think there's been a fabulous discussion on artificial intelligence, and luckily we have people that span a lot of different sciences here. What I would like to see discussed is when technology is put up on the board, of course artificial intelligence is quite prominent there, but what I was thinking of in line with what I said yesterday is what technologies are coming into play that can be used to probe scientifically. And I think we should just put that one aside and hit on that, or at least ask the question. I don't know, but let me give a quick example of what I'm talking about. Modern genomics, even modern molecular genetics, has become a major probe for paleoanthropology, or if you prefer for human history, for mapping migrations, etc., etc. What other technologies are there that we know of, and I might be somewhat ignorant of, that are pushing boundaries and laying out the agenda for science for the next 20, 30 years? And in particular, and this is on our board as well, using computation as an exploratory tool. It's up there under complex simulations. I definitely think that that's worth quite a bit of discussion. So very good so far, but those are the things I would like to say. What big technologies are opening up new fields in science, and what about exploratory computation?
Yes.
I think it was my intellectual grandfather, G.B.S. Haldane, who remarked that so far every invention that happened in technology has increased the difference between the rich and the poor. So I'm interested in what kind of consequences all that what we are discussing here has on the problem of inequality. Then I would like to say that this issue about the fitness or cost function in designing these maybe autonomous machines, agents, cognitive systems, is indeed very important, because there is an interesting lesson from evolutionary robotics. There have been many well-documented cases that you gave the cost function and the robot solved it by completely different means, right? So it didn't do what you thought the result of applying the cost function. Basically the system, okay, this is important, the system can be extremely opportunistic. And that is a danger. For example, I think that example was figured out by Stanislav Lem a long time ago in his Summa Technologiae in the 60s. So imagine that you are using a very advanced artificial intelligence system for monitoring, for arranging things in the country, because it's much better. Now imagine that the system notices that, for example, one of the Gauss functions was that try to watch that the population doesn't explode, okay? And then you put in some measures that that the robot can, or the super brain can apply. But then, since this is so advanced and it has big data, it might actually realize that there are some very weak correlations that help reduce population numbers in a certain area. And it might take an awful lot of time, until you realize that inadvertently this intelligence was administering kind of poisons to that area, about which nobody knew that it has a poisonous effect, but it realized the correlation, so nobody said it was a poison because this was not programmed, and therefore everybody gets poisoned with mild poisons, but cocktails of mild poisons in the area, and the result is beautiful, the population goes down.
Yeah, I'd like to pick up on something that, at the end of the talk yesterday, which is the Brain Initiative and what the consequences of that will have on not just our understanding of how our brain works, but how it will enhance potential for enhancing our cognitive functions. So it's all about innovative neurotechnologies. Now, I was on the committee that produced a report for the NIH on how they should set priorities. And we had a difficult time coming up with a goal that would be as transparent as putting a man on the moon, right? You could explain that to anybody on the Earth in one sentence, or you could just point to the moon. And that was an incredibly difficult thing to do because there isn't a single goal. When you say understanding the mind or the brain, there's two. That isn't something that is easy to put a metric on. How do you know if you've accomplished it, right? How far have you gotten? And interestingly, I came to the conclusion that that's the wrong question, okay, to ask. Really, you should be asking, how will the goals that you've set for yourself, how will those impact society? And my best example is man on the moon, right? So if that was so important a goal, why is it we haven't been back for, since 69, I think, when Neil Armstrong was on the moon? Well, the answer is that it's not economically valuable.
It was just a stunt.
Yeah.
It was an engineering stunt, and thereby
the Russians.
it was a geopolitical problem. It was a psychological issue, but also, interestingly, it was at today's dollars $100 billion investment into the infrastructure of the country, both in terms of engineering, building, and the impacts were it created a space industry. Communication satellites, weather satellites, spy satellites. And it wasn't just satellites. It created microelectronics industry because things had to be squeezed down, right, until the point where the cost of putting up a pound is very expensive. And if you think about it, in the 60s, our electronics was, in the 50s, right? That was vacuum tubes. And every single initiative since then has had that character. Like the war on cancer, we didn't win that war. But what we did was to create molecular tools, recombinant DNA technology, so that we could figure out that cancer is a genetic disease. And only now, like 40 years later, have we enough understanding of cancer to actually go in and target specific pathways. Human Genome Project, right? There was a study that was done by Battelle that for every dollar that was invested, $140 of economic activity have been produced. And it's not just in health, it's in agribusiness. And it's not just in terms of tangible things. It has completely changed biology, how we think about it. In the past, it was like one gene at a time, each lab with their own gene. But now you can interrogate all the genes. And so now you're looking at the system. And it's a very different world that we're living in. So what's going to be the impact of the BRAIN Initiative? There's going to be a neurotechnology industry that is, I think, as vibrant as the biotechnology industry that came out of the war on cancer, or the personalized precision medicine that's coming out of the Human Genome Project. And this is going to be a very interesting era because DARPA is already putting in arrays of electrodes into humans, not just for robot arms, but for enhancing memory.
Yeah.
And they're collecting data from humans, and they're stimulating the neurons, and it's only a matter of time before we have the right algorithms to be able to interrogate and also to have feedback to the point where you won't have to do anything physical to get a Google response.
Or vision.
Or you can put in, you can bypass your retina. You can create a new sensory input. You can become a bat.